Hi everyone, nice to meet you. Hi from Bulgaria, hi from Slovenia. I think that we are almost ready to start. Almost because probably it will be better to wait
В,
for 5 more minutes people to join
ти си
the
в
meeting.
Дискорда в QBron 150 и такова, нали?
And of course, if we have a little bit more patience, probably the community will be bigger. So let's give us 5 more minutes and start after that. Okay, perfect. Thank you. Okay, Alyosha, are you here?
Yes, we are here.
Perfect.
Hi.
Okay, I'll start presenting myself after that, you and of course Mr. Chetri after that with his starting of the performance. So, my name is Mariana Filipova and I'm the Bulgarian's team leader. So, here today with QSlovenia, we have the great pleasure to organize this workshop in the year of Quantum Science and Technologies 2025. Our event is one of the first ones that take places for Q World in this year. And also, I hope that we are going to have a lot of different kinds of activities during the year that comes, being much more together in a bigger network. So thank you very much for being part of the organization and being together today. So I'm giving you the word to present yourself and to tell us something about the event.
Uh, Hi, I'm Alyosha. I'm also the president of Q Slovenia. It's fourth or fifth event that we are making, and it's a very big pleasure to collaborate with friends from QBulgaria. So we are dealing a lot with the little personal quantum computer from the Spinku company from the China, and we will demonstrate it how it's working tomorrow at the beginning. First time tomorrow. Okay, bye bye.
Thank you very, very much. And now I'm giving the word to Dr. Amrit Chetri, so he to present himself because he has a lot to tell and to start with the workshop. Dr. Chetri, would you unmute yourself because we cannot hear you?
Good evening, everyone. Firstly, thank you all for this opportunity. Welcome to Q Bronze workshop from Q Bulgaria and Q Slovenia. With this workshop in quantum computing and programming, we are celebrating International Year of Quantum Science and Technology. Myself, I'm Amrit Chetri, the member of Q India, Q Cousin, and Q Education departments, as well as Q World. Firstly, thank you all for registering to this workshop, Q Bronze 152. I shall be leading this workshop with the help of the mentors, organizers, and other experts. In this workshop, I'll tell about the writing requirements of quantum programs, along with the help of the Q Bronze notebooks. To qualify for the final certificates, there are the sets of the requirement, such as quizzes and the assignments. We'll facilitate the participants to attempt some of the projects out of the given outlines at the end of the notebooks. This is to celebrate once again as the organizer, as the member of the Q World YQ 2025, as well as some of the initiative from AI Summit 2025. In one word, we are celebrating 100th years of Heisenberg uncertainty principles and his birth. This is the schedule that we'll be following in today's session. The whole workshop is divided into 4 sessions. First 2 in this week, that is 15th February and 16th. Next 2 will be, Next 2 sessions will be next week after a gap of a week on 22nd and 23rd of February. In today's session, this is the schedule. First is quick installation guides with the introduction to the quantum computing principles to make everyone aware of the working of quantum computing, different type of quantum models and the hardwares. And then we'll take to the scheduled topics, notebooks from the repository. The guidelines to install the Qiskit, which is the essential toolkits for this workshop, is given in the one of the URL that is also in the Discord. The Discord in our channel, it is given as one of the posts here. All are requested to follow the instruction given there. There is also the video part. Alternatively, who haven't done, so these are the steps I'll be following quickly here within 5 to 10 minutes. If you are in the Windows, good path to get into the one of the directory and then create one directory inside it. Maybe I've created the Q branch, similar directory there for this workshop. Let's say that is Q branch X, guiding as a considering some of the participants are the freshers. So here, this is time to create the one virtual environment, Python M, then M, B, and B, then give the name of the environment. So that could be Q branch 152X. These are the very simple ways to configure a separate environment, one for this workshop, and if there are other workshops in future, can create a separate environment, not to create any troubles or even to keep the 2 different versions separately. One right now is Qiskit 1.1 and other could be Qiskit 1.3.2. And also to maintain the sum of the codes if one workshop for the other workshop. So here are the rest of the steps to follow. all are requested to keep in the one of the study notes you will be preparing for this workshop, and it is going to work. All steps are tested. So once that is done, after that, can follow the steps to install the one of the editor or ID that that could be Jupyter Notebook or Jupyter Lab. So here is the Jupyter Lab. For that, can quickly follow the steps from Jupyter Lab official site. Anaconda is always great, which is a bit heavier than Jupyter Notebook. Anyone with the troubles of the resources can follow these steps, and will always get it working within few minutes. This is to install the notebook. Once it is installed, then Jupyter Notebook to execute it. So we have the environment ready. Once it is installed, next would be to test and check the few programs. Along with that, to clone the repository, follow the one of the URL which is given in the Discord as well as here in the chat box. Once this is added, next would be activating to activate it. So for that one, quickly go inside the newly created virtual environment and then activate it. So this is going to activate here. Now to get the repository, simply quickly clone the repository in the given location. So environment is ready. Next, to check the environment we configured just right now. For that, follow this Qiskit basics part, which will cover after the basic of the first section, that is classical bits and a quantum coin flipping section. On clicking this, we'll be able to test and verify the environment we configured just right now. The very first one is to check the Qiskit version. So here is the Qiskit version. It is installed successfully. In that sense, the very first requirement in writing any Qiskit program is to import the Qiskit object or package, which is the standard requirement of any Python code. If it is not installed, can follow this instruction or these commands from the Jupyter Notebook itself, which are given here. And next is to check one of the program. Again, in checking the program, a quick walkthrough of the program. First section of the code is to import all the necessary packets or objects. Here we are using four objects. One is the quantum register to create the quantum circuit, and the classical register to hold the values computed, and the quantum circuit, quantum register for the quantum bits, classical register for the calculation part, and then a quantum circuit to create the circuit using the quantum register and classical register. An AER object or class to create the simulator to run the circuit. After that, these are the way to create the circuit. First is creating QREG, basically registering the quantum register of 2 qubits, and then also creating the classical register of 2 bits. In the quantum register, it is qubits, and the classical register, it is a bit or bits. And to create the quantum circuit, it can go in the sequence of the register, but that should be the first one is a quantum register and second one is the classical register. After that, we are simply applying one header mark gate to check whether the program works or not. and then again XGet, and then the CNET get. And to know the result on applying these operators or the gets, we are measuring here, or this measure function measures the state after the 3 operations. It is working here. Now that means the installation is perfect and great. Next is to draw the one circuit using circuit.draw, which is a default function, and it gives the output on the basis of matplotlib. If this is not there, it's not going to draw like this. It will be slightly different, something like this. And by adding one argument inside the function draw, that's MPL means matplotlib. So in that case, it will be more intuitive, more clear, and precise. Next, with the help of the AIR simulator, this is the simulator from the Qiskit packages. We are trying to run for the 100 shots, 124 shots to know the outcome of the 2 different states, 01 and 10. It is well and is working fine. And to complete the test as needed here, these are the programs. Here also the similar structure, but the number of the operations are huge here. We'll be talking or will represent we'll discuss all this in the next notebooks. This is also working fine. Now we are moving. I'm moving to some basic understanding about, and to run the this circuit in quantum hardware, IBM Quantum, we need the account there, and then also the 2 separate packages. One is a Qiskit _IBM runtime, another is the Qiskit-IBM provider. In the next session, we'll be covering this to run on quantum hardware. So on that basis, here are the preparation for the hardware requirement, that is through IBM Quantum or on IBM Quantum. API key is required to run in any of the hardware. So that is available on installing the package and then writing the code, which is accessible inside this account, or every account probably, or yes, in every account can copy and use that. So please register this to the some of the question we'll answer at the end of the session, or once we have the question and answer session, Q&A session. Please create the account on IBM Quantum platform. Once the account is verified, there will be option to use the API token. This is done for one of the installation check. Going further, we would be doing the check. For that, I have shared the requirement, that is IBM Quantum. Similarly, that could be in IonQ as well as Azure Quantum platform. Next is to check the one of the last program in the installation, that is QBulgaria implementation. That would be the last sections of this workshop. For that, we'll be moving to the last section and to ensure that it's working fine. This is the implementation of Bursa's algorithm. At the end of these 4 workshops, all will understand this one. So here is the check to understand whether the environment is ready for that or not. Yeah, okay, this is also good and perfect. Now we are going to see how program can be executed in the hardware at the end of today's session. Now, let me move to the other details. This is a quick addition to the schedule topic, that is installation of package necessary for quantum machine learning. Although it's not the scope, but I'll try to cover some of the session on it to make everyone familiar in writing few sample or example codes in QML using Qiskit package. And one of the standard classifier in quantum machine learning is BQC, which is the variational quantum classifier. But there will be a special 15 minutes boot camp of session for this one to add some advantages over the Qiskit learning. Similarly, the program can be executed in the inbuilt hardware system and the simulator. One of the such simulator plus ID is Classic. Moving forward, would you please keep muted for some time? Would you please keep muted? Yeah, thank you. Now, these are the 10-minute session on understanding the basics of quantum principles and working of quantum computing. All are requested to be muted. Please be muted. Yeah, thank you very much. In these 10 minutes, we'll be covering the basics of quantum computing and then the types of quantum computing to add some value to the notebooks, which we would be covering or I'll be covering. The very first thing is quantum computing and quantum computer. It's basically a special type of the computation that leverages the principle of quantum mechanics to perform the calculations or operations in exponentially faster rate, but for a certain problem. That means quantum computer is not meant for all kinds of the problems. Quantum computing uses qubits instead of bits. Bits is 0 and 1, and qubits is 0 and superpositions. Quantum computer has both many kinds of advantages, such as exponentially speed up in the problem solving through the algorithms such as Shor's algorithm, Gruber's algorithm, in an efficient way for the molecular analysis and chemical reaction analysis. It is good in quantum powered optimization solution, such as quantum approximate optimization algorithm for a larger scale of problem solving. It is also really great for solving the problem or to deal with the calculations or manipulation, the calculation and prediction of large scale data sets. Those data sets may be from a business data lakehouse or maybe from some of the threat intelligence platform for the AI-enabled cybersecurity initiatives. In doing that, it is supported or powered by hybrid QML, which is a combination of the quantum computer plus classical computations. Going deeper, quantum mechanics. Quantum mechanics, or the principle of quantum mechanics, are the fundamental elements or the principles of quantum computer. It is also the fundamental theory of physics. In day-to-day life, we see many principles from quantum mechanics in our life, such as how sun do rise in the east, why there is a spring, all can be explained very well by fundamental theory of quantum mechanics. And it also describes the behavior of energy, behavior of matter at the atomic scale. In understanding quantum mechanics for quantum computer, can look at into some of the principle in deeper sight, and some of them could be or are wave particle duality. As for this one, the both a particle, quantum particles at the particle at the atomic scale behave both as the particle as well as a wave. And they can reside simultaneously in two different states, which is the superposition. Through certain principle, it behaves or showcase the entanglement as one of the property that helps the particle to connect at a distance, even they are really far away. And that is the one of the fundamental principle of working of quantum mechanics or the quantum computer too. Now, quantum mechanics or quantum principles have been used in designing various applications and solutions. One of the primary one is quantum computing or quantum computer. Others are creating the transistor and microelectronics or devices such as electronic atomic clock or what is called the sensor for the aerospace system, which are also based on the principle of quantum mechanics. And some of the principles of the lasers and MRI are also based on the quantum mechanics. Right now, our cyber security is being powered by quantum resistant security, which is through the quantum cryptography or post-quantum cryptography. This is something at the deeper side. We'll be going back to the fundamental parts, 1 qubit and others, once I'll finish this one. And there are two types of classification of quantum computing. One is based on the hardware implementation, another one is the computational model. And these are some of the names we have seen in the past. They are growing or adding some services to bring better quality of the computation for the futures. One of them is IBM. IBM has announced that by 2028, they would be able to bring the fault-tolerant computer for the mass use. And for the first superconducting qubits, trapped ion, photonic quantum computing, quantum dots, and neutral atoms, these are the types. In the second one, which is based on the computational model, IBM Q, D-Webs, and Microsoft Quantum, they are the prominent player. Current approach for quantum computing are based on the availability of the present system. They are of four types. Quantum simulator, the one I demonstrated, that is a simulator from the packages. Then the cloud-based hardware, miniature quantum computer, and the personal quantum computer. Now, there are some great products for all of the four types. For Qiskit, for the simulator, we have the Qiskit AER. For the cloud-based system, IBM Q, IonQ. They are the great names and the players in cloud-based hardware type of computation. For miniature, IBM released one of the product in 2017, probably, somewhere around, by the name of IBM Quantum System 1 for the university, college, even for the personal institutions or the home. Right now is not a personal computer, but can be used in some of the institutions or establishment. And we also have the personal quantum computer by the name of Quaka. It was used in one of the hackathon recently in 2024 by Quantum AI from Poland, QPoland. Now, this is the set of the different types of the quantum computers to use. Now, here we'll be using two. One is the quantum simulator, another is the cloud-based real hardware. This is again said that we all, as a community celebrating IQY, now moving to the different set of our Qiskit notebooks and QBronze notebooks. Now here as scheduled, I'll be starting with the 1 qubit. Before that, I'll check some of the questions in the chat box. If any question, please send in the chat box for a few minutes. And for those who have the queries and not been answered, I suggest you all can send the queries or any doubts in the Discord channel. The mentor or myself, an organizer, will feel good on answering them back. If something urgent or something to answer right now, please feel open to share your question for 5 minutes. Yeah, Mr. Roman, you said that how to install in the Mac OS. The steps would be similar, and I already shared these steps. Just keep the Python running there. After that, follow these steps like this, which again in your chat box here. Steps in Mac OS as well as other version of the Linux would be same, just like in the Windows, provided the installation of Python would be slightly different. Okay, there are no questions, so let me move forward with the first part of the notebooks, that is 1-bit. So far, we understood there are two kinds of systems. One is the classical, another is the quantum systems as the medium of computations. The first one, the classical, works on the principles or using the power of qubit, using the units, the basic units, that is 0 and 1, which are bits. In electronic circuits, they are just the state, and those state represents are in the form of 0 and 1, and which are the working units of classical computers. And each of the operations in classical computers are carried out by different operators to a single unit first, a single qubit, or in other words, we can apply 4 different kind of operator to a single bit. Identity, that is represented by I. On applying it, if it is 0, it gives 0, and if it is 1, it gives 1. Negation, that is not operator. If it is 0, it is 1, and if it is 1, it is 0, just opposite of that one. And for the constant 0 and constant 1, whether the value is 0 or 1, it will always be either 0 or 1. So these are the 4 different types of the operator we do apply to the classical bits or single classical bit. This is the table representation of the final state and then the initial state. When you draw the state, initial state, and the right top at 0 and 1, and the final state in other side, then it is possible if it is moving from one to another, where it will be going. This goes to indicates the state. In 0 and 1 form, the initial state is 0, and this is for the here the operator. The operator, the first one is what is called identity operator. In identity operator, if we start with 1, then the final state has to be 1. So here, if you look at into the state, this is highlighted 1, and then the final state here, the cross section of that one, or the geometric cross section of the first one, and the final state will be your final state. So in that case, this value here, 1 is the final state. Started with 1. If it is, if we apply the identity operator 1 to 1, where it will be. So this is for 1, and the final state is going to be 1. So these are the explanation. Can quickly look at into the details here. This is the slide, details, and other will also, or other follows the similar one. So for the NOT, when you apply the NOT gate, as for this one, if it is 0, it has to be 1, and if it is 1, and that is going to be 0. Just opposite of that one. So in this case, if it is initially state is 1, and if you apply the NOT gate, then in that case, 1 is here, 1 is there. So final state or the final result will be 0. Similarly, for the others. For the 1, here is 0, this is the initial state, and then in the final state is 0. So the cross of that one is 0 here. That means the state is going to be 0 here. Yeah. Now we'll have some reversibility and irreversibility. There are two kinds of the operator. After applying the operator, if it is coming back to the initial state, that is we call the operator is called the reversible operator. And if it is not allowing to come the system back to the initial state, which is called irreversible operator. In that case, I and not are the two operators which are also the fundamental operators, and they are the reversible operators. Here, identity and not operators are the two fundamental operators of quantum operators as well as in the classical operators. Right now, we are looking into the classical, so it is true for the quantum. I think probably this is correct. Now going to the coin flipping experiment and then some of the problem solvings around that one. A coin can have two states, and here we are considering considering unbiased coin, which is called the fair coin. In this one, there are only two states, either the head or the tails. Head is represented by 0 and tails is represented by 1. And the probability of getting head is 50% and probability of getting tails is also 50%. So in this case, if you represent the head and tail as 0 and 1, the probability is represented in this way. The fair coin is its operation, and because it is already known. So here head is 1/2, which is nothing but the 50%. As it has only the two states, the probability of getting one state is just 50% of the others. Now we are executing one Python code to see the probability of getting 0, that is heads, and the coins, which is 1, tails, that is 1, for the different number of the execution. In this Python code, first to use the one class that is randRange to generate the random number. And here are the number of the sorts or the number of the executions to check or toss, you can say, tosses. And initially the 0, then after that, we are increasing the number of the counts for the heads and tails. On running it, for the experiment, 100 tosses, the probability, the number of the heads is 43 and the number of the tails is 57. And the ratio is given here. In contrast to the fair coin, there is a biased coin, which is not always 50% or may not be in just a head and tails. or is not always 50-50%. It can be head and tails, but not always 50-50%. In the bias coins, if we take one of these, example is not always even the 0.6% or 0.4%, but is the probability if we consider like this table, in that case, the probability of getting heads is greater than the probability of getting the tails as per these distributions or this set of the table. In simulating this one in Python, we would be running the similar code, but instead of 50%, there is a clause to count the probability of getting heads is 60% as 40% for the tail or the tails. So here is the solution. This is the second, so this is the first one, and here is the second one. In this one, the head and the tail, this is the initial state. Again, if it is the head and toss there, the probability of getting head is 0.6 using the initial table. It has to be the cross section of the head. In that case, if we started with the head, then 0.6%. If it is a tail, and that is 0.4%. Now here is a clause. It is, if it is lesser than 60% for the heads, in that case, it is counting, because maximum counts we consider in the program is just 60% of the 6/4 in the ratio form. There is a task to check afterwards. Just find some minutes to go through it. Now it is possible to program a biased coin, or we can generate the biased coin for experiment or also to understand. So in creating the biased coin, first to consider the range. Let's say we try the probabilities of n. We pick a range of n and then assigning some value to them. And we fix the sum of the random number. I'll pick the sum of the random number between 0 to n or n-1. It can be, it can be n-1. And then applying the logic, we'll be able to get some random numbers which belongs to one real number set 0 to n. So here is a solution. There's a task 3. This is just a solution to create the bias coin for the random number. And then it is taking the one set of the range. It will be up to this n-1 because here it is excluded. So in that case, it can be n+1. And then returning either the heads and tails on the basis of this second parameter. So it is created, and the task 4 is to apply that one to check what will be the probability by giving some number to it. As this is a function that takes the first argument is the range, and the second one, as we defined, is the maximum head count it can have. Earlier it was 60. Right now we are supplying the numbers here. So here is the another function to supply to the rand range to get the number b. It is randomly generated, and here is the total toss of 5,000, and then checking the guess and the error factor. There is an error of the 2.3%, and the real bias is 0.2%, and my guess, but what we guess is almost 0.4% correct. So in that case, this is how we can generate the bias coins. Now here we'll be starting with the probabilistic bits. If we consider a coin as a system of two states, that head and tails, then we can say the one iteration of each state is 0 and 1 with a probability of a given outcome. So in this case, 0.3 and 0.7. Or in other words, if we consider a probabilistic states with a probability of 0.3 for head and 0.7 for tails, in that case, that is one probabilistic set of the bits. In understanding that, here is a one game, and in the game, Ezra has to toss the coin, and doing the toss, the probability of getting the heads is 0.6% and probability of getting tails is 0.4%. And if she does the same thing for the another one, that is for another cent, another coin, the probability just swaps. That is not swaps, is different. That is 0.3 for the heads and 0.7 for the tails. After doing that protocol, or after following that protocol in flipping the coins, here are the probability how we can see in the game. Now the first is for the first one, head and head. That means 0.6% for the tail and tail, that is 0.7%. If we represent that one by the number that is 0 and 1, so in that case, the heads, which is 0, and here also 0. The probability of getting heads is 0.6%. And writing the code here, this is the solution to get the in tracing the 10 bias coins and then the results. Probability of head after 10 coin tosses is this one. This is again based on the initial program, that is the use of the range and the other construct here, that is new head tossing here by using the numbers out there is not always fixed, because if you are getting the number, means we consider that the probability of getting head as 0.6% and probability of getting tail for the first one is 0.3%. But for the others, it is different. On that basis, this calculation, the overall probability of getting heads after 10 tosses is 0.4%, and for the tail, it is 0.5%. Next is representing the probabilities as a column or the vector. In any of the experiment we completed, there are two outcomes. Either two different states we consider are the states of different values. In that case, it's possible to combine all those values to represent as the vector. If you use the two-size vector to represent the earlier state, which can be represented as like this. For the very first experiment, that is for the fear coin, we have 50% of getting the heads and 50% getting the tails. That can be represented as this vector of 0.5 and 0.5. For the second one, there was a probability of 75 and 25%, which can be represented as the vector like this one. In the task one, we'll try to understand the probability of flipping the coin in the ratio of 1:4. And this one in the in the task 2, we'll look at into the task 2, which is the dice. In a dice, there are 6 different sides, and the probability can be represented as a probability 1, which is the probability of getting this face with the number 1, and probability 2, which is the face of 2. And in writing the code, it can be represented or can be written like this. Suppose Hydor tosses a tricky dice, any dice, with a bias. That's not fair because it can be in any state. And the probability of like this, or probability in this one, the probability of first one is 7, the probability in that way, in that order. And if we try to convert that into the program, it would like this one. The first is to represent the position or the portion. That is 7, 5, 6, any random position, generate the that can be in the state. Then total portion, the total portion, of course, is the 6. And here in calculating the ratio, the total portion per all portion, every time we are checking how many times a portion is coming. So after that, it printing here the total portion. At a time, it gives 1, but that will be added to the total portion. And if we run this one, what we'll get is the probability of getting 1 face at a time. Probability of getting 1 is 0.28%, and probability of getting 2 is 0.2%. Just follow the program. If any doubts, you can send the queries in the Discord channel, as well as can contact in private in Discord only. The second one is for a system of 4 states. If we create a probability state that can be like this, the 4 different states, and just like this one, we would be able to write the different state using Python code. Now next is the next section. We'll try to understand how these states are manipulated by probabilistic operators. "90 minutes, almost 30 minutes more. Now, a few minutes back in the last slides, we look at into how we can use the table to represent the state or final state. And where there are 2 different examples, one is the biased coin, another one is the unbiased coin. And initial state can be 0 and 1, depending upon the state selected. That's also true for the circuit. And any state 0 can be represented as the set of the vector elements V0, which is for the V0 is vector of 1 and 0. And if it is the state 1, that can be represented as vector 1 or vector of 0 and 1. This is a general convention to write initially. Just if it's for the vector state 0, this has to be the first bit is 1. And here also, if we look at into the state here after flipping the coin, current state for any of the system have to be 1 state, either the tail or the probability is the one of the chances whether a state will come or not. In that probability, either of the 1 state, that is either the head or tail, will be there. So right now is the state of 0 as represented here. So that can be written in a vector form like this. Current state, that is B0 as vector of 1 and 0. An entry to the new vector is calculated as the by the row vector in the current system. Each entry to the new vector, I mean to say, or you mean to understand, in this vector, if there is a new vector that can be added to get the another state, and in doing that, this is the calculation. We'll do some calculation afterwards. After the second flip, there are two different flips we calculated in the previous state. My state would be different one. So initially it was just one state, that is the current state. Initial state was the state 0, which has been represented here. And the current state is the state we calculated in this one. So if it is head, and head is 0.6, and for the tail, there's a tail that is 0.4. For the head, that was started with the only the for the head 0. So for the head, even in that case, 0.4. So this is 0.6 and 0.4. Yeah, that is started with the head. So in that case, that has to be 0 and 4. As we represent after the second flip, it is going to be 0, 6 and 0, 4. Now coming to the probabilistic operator. Any probabilistic operator is represented as the matrix or the table of the vector. And it is always non-negative value, which is represented as R as the real numbers. Now, when we apply such kind of the operator, they are applied to the some set of the operand. And right now, operand are the one state or maybe a set of the states. In this one, we represented game has the matrix, which is the initial state. And if there is operator, then they can be applied, they can be multiplied to get the final state. In this one, the first task, the operator game coins, this is the one of the operator, game coins is one operator with the matrix 0, 6, matrix of 0, 6, 0, 3, 0, 4, 0, 7, applied to the probabilistic state of this one. And on applying that, it gives the new probabilistic state on the basis of vector calculation, and which is the 0.3 and 0.67. So in summary, a probabilistic operator can be applied to the probabilistic state, or operator can be applied to a probabilistic state to get the new state. And that state is calculated on the basis of the calculation as done here. And when you represent a probabilistic operator, which is of the 3 by 3 dimension, in that case, second state can be calculated by using either by the manual calculation or by the set of the Python code. Once again, going off in this one, this is the one operator here. And the second has the state. On applying the operator, this is the second operator. Second part is the operator, and the first part is the operator, and the second part is the, you can say, as the operand and the state. On applying that one, it performs the one vector multiplication, and that gives the final state. Now the task 2, we have the following probabilistic operator, means this operator, and we are trying to see the transition. If it is going from the state 1 to state 2, what would be the transition? This is very important, and here is the one very nice explanation by this slide, this, what is called quote. I mean to say this solution, instead of quote, it is a solution. Just feel relaxed to get into this one. So here are the 3 different states, the state 1, state 2, state 3. And here are the similar state in the final state. Now, in understanding this table, first thing, we'll take an example. Moving from the second state to the third state. In that case, the from state has to be the row in the top. This is the from state. So in that case, it is going from the second. So second is here blue in color, and going to the third state that you have to select in the column. So in that case, this is the third, that is S3. And by looking into the cross of the from to to, you could get the probability or the value for that transition. So in that case, it is 3. Similarly, the transition from the third to first. So from third, this is have to be in the top, and to the third to the first, and the first one in the column, that's 2 is to be the column. So here is the columns, and the cross section is 0. So value is 0 here. And this is there in some quizzes, as well as it is how it is calculated or mapped in this table. Transition from the first state to the second state. So in that case, the first one is in the row in the right top, and then the two state, which is the final state, is to be in the column, and the value is here inside this section. Here you can see inside this section, I'm not using any pointer here. So this is highlighted again in the blue. So this will be the final state in transition from the first to the second one. Now task 3. Randomly, we are going to construct, this task is to create a 3 by 3 dimensional probabilistic operator. Again, at the top, you understood that operator is applied to the operand, and operand here we consider as the state. Now this is to create the 3 by 3 dimensional probabilistic operator. This is to randomly generate one matrix. Very simple. So here is the solution. Initially, there is a blank matrices, or it is a list of value 0, 0. So with this program, this will be populated in each of these placeholder, or the 0 value will be populated or updated with the corresponding value. So here is a matrix of a 3 by 3 before normalization, and the second one is after normalization. Any doubt in the code, just feel open to share the doubts and queries in the Discord channel. Now this is another task. What is the probabilistic state if the operator, this one, apply to this one? This is basically to multiply this state. The second one is the state with the operator. In doing that, here is a solution. And writing code would take a bit practice. And here is the solution for that one, fourth one. Initially, this is the state, and this is the operator. Operator B is a list of the operator value, which is already given here. This is B is the operator, and then the state, which is B, and new state, which is initially blank, and applying that, a new state append 0, and for I in the range, which is the length of the row, and the new state along with this index here, here one flag here, index new state the value on multiplying each of the element of the second one, and that gives a new state. So this is the new state after applying that operator for a given state. This is to write a linear function that takes the probabilistic operator and the state, then returns the probabilistic state back. Is again the similar program, but instead of just one, it takes a set of the values at the initial state. So here it is the solution. In doing that, it uses the one external Python file, which is given at the inclusion site. This is task 5. Instead of a fixed one, it takes the operator and the state. This is a more generalized solution to understand the probabilistic state of any operator or any state. This is the one new state for this one using the new code. This is a B, and B, instead of just doing the calculation like earlier, it uses the standard one, you can say, API call to the given problem or the given state. Here also for the second one, this is the probability state after applying one operator, new state, and the new, this is B, which is the operator. Now we talked about the two, one probabilistic operator. Now probabilistic operator for the 1 bits. Next is to look at into the similar operations and similar state, but for the 2 different bits. We consider 2 bits are there, and their initial states are this one. The first bit has 0 to 08 as a vector state, and another has 06 and 0. 0, not 06, 0.6 and 0.4. If we combine the state, that will be a combined state of both of the bits. And now next, to understand how they are calculated using tensor product. Initially, both 0, 0, both bits are in the initial state of 0. This is the representation for different states they can have. 4 different states they can have, a combination of states. Both of them are in 0, 0 state, is represented by writing 0, 0. If the first one is the state 0 and the 1, that is written like 0, 1. And the next combination is 1 and 0, that means first bit is in the state of 1 and second one is in the state of 0. And the last one, both of them are in the state 1. Now, first thing is to understand the representation of the different states. What are the probabilistic state of the state? Probabilities of being in the state 0, 1, 1, 0, 0, 1, and 1, 1. Means what are the probabilities of getting in different states for the 2-bit system? In the vector representation, we understood that state 0 is 1, 0. Similarly, the vector representation of state 1 is 0, 1. And if we use the vector node for 0, it will be vector of 1 represented as vector matrix of 1 and 0, matrix 0. And similarly, for 1, it is represented in the same matrix here. The probability state 0, 2, 0.2, and 0.8 can be represented in the form of amplitude plus the state 0, 2, then the vector of 0, the matrix of 0 plus 0.8, the matrix of 1. So in that case, the first one is the probabilistic value or the probability of being in the given state. 0, 2 represents the probability of being in the state 0, and 0, 8 represents the probability of being in the state 1. Similarly, if we consider the another system, so it is going to be 0.6 and the matrix of 1 and 0.4 matrix of 0.6 matrix of 0 and 0 plus 0.4 matrix of 1. So again, 0.4 is the amplitude, and that is basically here the probability of being in the state 1. Now the next is composite system. Composite system is comprises of two different systems. Or in other words, in composite system, we have to calculate or need to calculate the states of two different systems and their states. When the two systems are composed, then their states are not joined, not added, but they are tensored. That means tensor operator is used to get the final state of the two composite system or two systems in calculating their states. Let's consider the first as we already taken here. There is a state of this one in the linear representation, and the second has this representation. In calculating the composite state, can apply the tensor product or the tensor calculation to get the final state. So on applying that, can take this 0, 6 and 0, 4 out and can apply an operator for the 0 and 1 bits inside. So here is a one calculation. Firstly, 0.3, 0.7, take this out in the one bracket and apply the tensor product for the state value, that is the matrix 1 tensor of matrix 0. So it is going to be 21.7, and when you apply this as per the rule, it is going to combine, and if the first one, that will be apply one operator. If it is 0 in the second one, that's will be keeping as in the second bit, that is 0. So in that case, the total calculation here after applying the tensor is 0.21 and 10. So here is a Python-based solution for this calculation. Now, the first is the state and is being applied like this. And here are the total calculation to get the final state in terms of the amplitude representation as calculated here. Again, to say that this is a tensor product of the two different states, as it is from the two different systems, is a composite of two different state, the state of the first one and the state of the second one, and which is calculated by using the tensor product here. Now, initially, it has the state like this. This is the state composite system. And then by applying this, we would get the final state of both the system, final state of the composite system in this form. I have the schedule right now. Okay. If anything, again, exercises and would be presenting more on the same along with the other topics in the 1 qubit while presenting the quantum qubit system, as these are the classical concept in writing and understanding some of the concept in the quantum system. So here are some exercises. Now here I'll be asking some questions, and to run these exercises, first just run it. You'll get some question to practice. Now, first question. The sum of the state is always 1. In a vector representation, the column, if this is representing the state of probabilistic system or the probabilistic states, then the sum of the values is always 1. So this is the hint. So what is the right answer? Please send in the chat box. Any guess? What would be the right answer for this one? Here only for 4 to 5 questions, as started 10 minutes late. I'll be taking up another 14 minutes. As there is a schedule talk or the events, although I'll just allow to finish myself, I think, on time, as there is another scheduled talk. Now here, to give a revision, the sum should be 1. So in that case, 0.1, 0.1, 0.4. So in that this is 0, that means it should be 0.6. The sum is 4. So here, these are the value here. If we sum up all of them, keeping this as a x plus 3.1, 0.3 plus 0.1 plus 0 has to be 1. So in that case, the sum of this will be 0.4. If I minus that from 1, so that is going to give me 0.6. Now, even for the probabilistic operator, sum of the column is always 1. So in that case, the first gives me 0.3, second gives me 0.8. That means this is the right answer here. For this system, the first one gives 0.5, 0.6, that's 0.4, this is 7, 1.1, and this is going to give us 0.4, that means 1.5. So similarly, can calculate the others. So before attempting the real quiz, visit this one to practice the exercises in classical bits. The next is quantum coin flipping. Will be taking only 5 minutes as we started, I think 10 minutes late. I just want to beg for another 10 minutes. I think, yeah, 10 minutes. Now, this is a photon double slit experiment. In the first experiment, 2 photon detector and 1 source, that is photon source, was installed. And the observation was to see the probability of getting 0 state or 1 state, or passing through the splitter or being reflected. It is always 50-50%. And going further, the next one, a mirror was placed instead of the what is called the detector, or the another coin, another what is called mirror. So in that case, it has a different result. So for this one, the probability of getting 0 state is 25%, and probability of getting state 1 is again 25%, and being reflected into the state of 1 is 50%. So here, that means the probability of being in the state 1 is 50%. If it is going into the other, that will be 50%. That would lead to the final state of that one into state 0 and state 1. Now, similarly, the other experiments were done. So in this one, there is one game to play to have some fun here by adding different controls there from this intuitive video game, online game on running the states, or running the double slit experiment through this quantumflytrap.com. This is the one website. This is already in the slide. Please open and then start by clicking on this one. Add the control as much as you want here, and then just play to see the results here, where it's at the top. Now it gives, this is the detector, and one is eating it, another is detecting it. So by this experiment, it gives the probability of being in 1 state, or also can add the one more detector here just to replicate the experiment given in this slide, and just observe what will be the outcome of the given experiment. Now, going to the next one is the first quantum program with Qiskit. So far, we understood operator is applied to the state, and that gives the new state. Same concept is also true for the quantum operations. Now here, there are 3 things. One is the operator, which is applied to the state of the quantum system. Before that, the quantum computation as it's working. A quantum system works in qubit, which is basically a state that's basically a superposition of 0 and 1. And on applying the different operator, those states are changed to get the new state. And circuit is created to apply the operator to the operand, and that means those state by applying the skills learned or the acquired so far. So here is the simple circuit example. First is to import the necessary object. Here as said, the quantum register, classical register, and quantum circuit. Second one is registering one single bit using register, similarly one classical bit. The first one is the quantum bit, which is the qubit. Instead of quantum bit, that is a qubit, that's also true. And another one is the classical register, that is one bit, classical bit, which is bit only. And by creating a quantum circuit, we can use them. And then next is to apply the one of the operators. So here, one operator is the X operator. And operator is a part of the different operations which are done in the given state or for a given set of the state. And applying that, next is to see the state, which is done by the measure function. And here we are running it to get this circuit. Now on drawing it, this one, and the output can be using matplotlib like this. And further going to check what would be the outcome of this one, what will be the result on a given state. So initially it is 0. When we created one circuit, it is the 1 bit. That means the initial state of that bit or that qubit is 0. On applying those 3 operations here, 2 operations or one operation, what is the outcome? So we can see that should be 1. So let's run it and see. Yeah, now that X gate had changed the state from 0 to 1. So we successfully demonstrated the use of this one. Now on applying the Hadamard gate, we would get different result. You can see the probability of getting 0 is 515 times, and number of the times we got the 0 is 513 times, and the number of 1 is 511. So in that case, the probability, not probability, the state of 0 is being superimposed using Hadamard gate. So it shows that Hadamard gate superimposes or created the superimposition of a given state that initially 0. So thank you all. This much for today's session. So we have the other great events, great talks to come from some of the experts from the industry. And thank you all. And you all can send the query in the Discord. And I felt really honored, as well as I think it was quite smooth in terms of showing the examples, concept. The expectation out of this session, you all would be able to run the programs demonstrated, as well as practice all the exercises and get ready to attempt all the four different assignments on time, not before a few hours of the deadline, but just before few days or even few weeks of the deadline. So thank you all. And now Maria, is your turn, or this virtual stage is yours?
Thank you very much, Dr. Chetri. It was a really great presentation, and I hope that the discussion, the knowledge, and the questions are just in their beginning, and we'll have 2 amazing weeks for that. So I'm going to share my screen now. Okay, So I'm going to present today about the applications and career development in the quantum field. And I've prepared for you a little presentation about that. Because always arise the questions, is now is the time for that, or what applications we may find for every one of us. And having such big knowledge, what are after that the realizations in the field. And I will try to answer some of these questions, what is expected from us, and what are the possibilities around the globe. So it is interesting probably to read such articles and materials connected to the 21st century skills on the one hand, and the 21st century skills possibilities around the world. And I have an article in the Quantum Technology Insider, which would be interesting, I think, for you, about how from quantum education and outreach we may reach the quantum workforce possibilities, and how to build these bridges, and as it is very popular to say, filling the gaps that we have not only in the workforce development but also in our career development. And probably I will start with that every one of us has such a questions: am I on the right path? Nobody around me understand me, or there are not so many people that do, and what are the next steps about it? But I'll answer with statistics that is famous worldwide, and it says that the quantum industry is going to generate more than $1 trillion in the next 10 years, talking from now, because now 2025 was proclaimed for the year of quantum technologies and science and so around the world by UNESCO and United Nations. And it is not by chance, it is of course because of the tendencies in the next 10 years that are coming to us. And that already in this year we expect more than 50% or half of all the quantum jobs around the world not to be possible to be filled, uh, no matter what are the qualifications, the status, the potential of everyone who is graduated. And the statistic is, if we use all the graduated persons, so actually the free places will be much more. What are the opportunities? The opportunities I have divided into different aspects. One is the academia, and the other one is the business sector. I'll start with the academia with two absolutely real possibilities that exist nowadays in the Google network or in another networks too. I'm going to speak about that a little bit later. But for example, I have selected here an opportunity from Rochester Institute of Technology in USA, and also one that is from another continent, from the Kingston University. Why this different kind of jobs? Because they're in very far places from each other on the one hand, so there are possibilities locally for different people, and for their content or expectations from the applicants too. One of them is for a physicist, something that is very expected in the quantum area. And the other one is an investigation of quantum cognition in financial decision making. So quantum might be a very large scale and potential in learning and also in realization that we're going to see in the next years. So my suggestion for that is to think about the realization in quantum globally, not just what we have in our town, what we have in our country, what we have in our continent. Now, with the global network, we can be trainees on another continent. We are possible uh, to be applicants for different jobs or PhDs or post-PhDs, internships, volunteering teams all around the world. They might be entirely online, they might be with a relocation, they might be in a hybrid way, etc., etc. So don't think in the box, but go outside of the box and try to be confident and to learn. And that will give you a lot of opportunities. And such an opportunity is now the popular university in Spain. There is a master's degree in quantum technologies that is entirely online. So you don't need to be relocated there or to have some kind of eligibility. Everyone is eligible if he or she is accepted for the program. So it is in English, and every year starts a new course until 29th of May. So the open new year application will be on the 10th of March till 29th of May. Everyone is possible to apply and to start learning and having, of course, a diploma in the area. The business also hires in different fields with different aspects and possibilities to realize in the quantum sector. If we speak about Europe, the possibilities are very much and very popular in UK, in Germany. Here you see some kind of possibilities in Fraunhofer and also in other places. And if we speak about Asia, China, Japan, Singapore, and India are also very famous with their possibilities. Of course, not only, but a lot of other countries also have different suggestions, proposals, openings every time. And for the North and South America, of course, biggest and biggest. I hope that following our social networks, you will know much more about that in the upcoming months during the year, because in the year of quantum we have prepared a lot of activities on the one hand. On the other hand, we are in connection with different organizations and making collaborations and also organizing some hackathons, and it will be possible to understand for them the next days, weeks, and months. I have decided to point out 6 career strategies for building a career in the field. So one of them, or the first of them, is don't apply through LinkedIn and apply directly to the employer. If you have chosen some labor market opening, don't apply directly to LinkedIn, because probably the provider of the job will not receive your application, and of course you will wait and will ask yourself what is happening with my application. I have no feedback. So please try to find the provider directly and apply to the company, to their email, and that is the great strategy. Your application, your CV, to be reached to the proper part. Second suggestion is don't think about quantum as a limited field. Everyone says, yes, it's a very open sector. Yes, it is a multidisciplinary field, but it is only for mathematics, physics, computer science, and engineering. I would like to open much more this field, because there is quantum biology, quantum chemistry, quantum pharmacy, quantum business, quantum finances, quantum management, quantum project management, quantum project creation, etc., etc. So in the future, there will be much more openings, and don't think that this integration of the subjects is only for 4 of them that we can see always to be mentioned. The third suggestion is look for the opportunities globally. I will not go in deep right now again in this section, because for the next slides I will pay a special attention to that. And the next one is that you can be also an entrepreneur with own startup ideas, and it is not only limited to work for somebody and to search for a job opening that you don't feel it is something that is really the yours one, and you don't see yourself in this role. That means that you don't fit in the market. That is not true, because probably you will be the person who is going to invent something new. You will be the creator, the innovator, and the person who is going to realize something that the others haven't been seen till this moment, and not only to realize something great for you, but to the others in addition. 5 is the next 10 years, the quantum industry will be a focus, as we saw. So it is something that will grow, and you should really use this fact, because the career opportunities will become much more. So don't give up, and try to enlarge your knowledge every day, and to try to be active in searching these opportunities too. The last one here is about the solutions for your career opportunities in all directions. We will see the applications in industries like healthcare, energy efficiency, banking and finances, education and much more. So try to look at quantum as something that is unlimited, really, and try to find jobs or to create such with you, realizing your own ideas. How to do it? just be active. Nobody, or there are not so many people that really know at the beginning of their career how to reach some aim. But if they are sufficiently active, they will reach their dreams, and they will obtain much more opportunities to try to do different things. So this will give them at first knowledge, after that building connections, and also to gain some experience. Also, something important is that you should use all your personal skills when you would like to be realized on the global market. Use all your knowledge that you have in programming, all your knowledge about being a community person, about participations and presentation in workshops and conferences, etc., etc. All this knowledge and skills in combination will give you the best realization today, tomorrow, and the day after tomorrow, because with every step ahead, you're becoming better and better in your work. Okay. And of course, have a strategy. At first, it is good to find what you like in quantum and what you don't like in it, because always we have some branches that are our most favorite, and other ones that we are not so attracted to. And in searching and participating in different activities, programs, workshops, we see, yes, it is for me, or thank you for being part of it, but I see that this is not actually for me. And it is very important, because this kind of way you will also form the idea what path I would like to follow, what kind of job, what I'm going to realize, or what not. So having a lot of workshops behind you, a lot of certifications, make you with a bigger portfolio on the one hand, and to the other with some kind of experience that answers you to a lot of questions. Participate in the internships and training programs. So you're not only your theoretical knowledge to be the weight of your portfolio, but also the practical skills you might reach in such opportunities. Also, the team playing and the exchange of knowledge is valuable too. Stay updated with the trends and research. So if you do some kind of work that is very in deep, is very well, that you will become professional with it, but it's a kind of problem if you don't look around to hear and to see what the other people do right now around you or on the other part of the world. What are the innovations, what have changed to the market, because it will give you probably a lot of knowledge, but will keep you in the box, and we don't know actually this to happen. And as I mentioned, the soft skills are also part of your personal skill development. So improve your communication, problem solving abilities, and prepare for your great performance as a whole personality. Follow your quantum dreams without having doubt for it. And as much you prepare, you become much closer to the success and the desired aim that you will form during this way. Embrace the changes, stay flexible, and try to fit with the environment, no matter that you should have your own opinion, and sometimes it might not be the same as the people around you. That is the most valuable. The big companies like IBM, Amazon, and a lot of different have always teams that are from very, very different people, like kind of thinking, education, experience, skills, and when they start to make the brainstorming of the task they have till all the way they resolve something unique, some innovations. They are in a collaboration with people that are different thinkers from them, not the same one, and that is the very valuable thing. That is why they have such a big success. And be collaborative as much as possible in as much as activities you can find in the world, because the opportunities come from there. And again, from campus to the career, how, of course, with university education, with the additional growth you will achieve in the active involvement, trainings, internships, trainees, engagement, and volunteering initiatives worldwide, with the portfolio development, adaptiveness, mentorships and networking, personal projects and research, and of course with a great portfolio that will catch the eye of the HRs, that also will have change in their professions, because they will hire people from quantum, so that means they will also have different kind of expectations for their jobs very soon, and how to perform in the interview with a great personal skills, how to search the jobs. Yes, the big companies, we know that directly is a good way, but also there are places where you might find different kind of jobs from different companies. One of them is the European Quantum Industry Consortium. There you might find a lot of jobs from distinct publishers from different companies. I mean, after that, SIP Recruiter is a good place, quantum technology recruiting also, and indeed is like LinkedIn. So there, find something that you like, but after that, search for the company and to apply directly, and not via the site, because as LinkedIn loses your job application and is not received by the job hire, here is the same, so apply directly to the company you're interested in. Also, if you want to be active, you might volunteer with us. Actually, QBulgaria is part with one of its teams from STEM Academy, and it is one of the branches you have. So QBulgaria organizes workshops and communities. On the other hand, we have the first school in quantum science and technologies around the world. That is STEM Academy Quantum School. So we teach students, we teach teachers, because when they're with us, they have to have their personal growth. And on the other hand, we also have initiatives for teaching other teachers that are interested in quantum. In the next month, we have another workshop for teachers in school ages, in different fields that is going to be on the topic of mathematical cryptography to quantum cryptography, and how to be incorporated in the different subjects in the school curriculum. Also, we have project teams for collaborations and partnerships. It is a new one. We have already 6 writing teams due to the big interest around the world. We help the scholars from the school to make a research in their school ages with it. Also, they learn about quantum and how to write academic papers in the help of enthusiasts and also professionals in the field, and design the quantum science of the future, preparing papers that become part of the world scientific community. Also, we have content creation and lecturing part, where we have guest speakers, mentors, content writers, etc., etc. And I would like to quote here a famous literature person that is from UK, and he said, hardship often prepares ordinary people for an extraordinary destiny. So when you find the way very difficult and not so thankful as you expect, please remember for that and keep doing ahead. And thank you very much for your attention. Thank you very much for being with us today. So before we stop the session, I'll be happy to hear your questions, to, yeah, if you have something to share. Thank you very much once again. Okay, perfect. If not, again, we may say thank you very much for being together today. And tomorrow at the same time, let's start, let's continue until there's time to be together in Discord. See you. Bye.
Bye bye.
Bye. Have a good day.
Bye bye. Bye. Have a great day.